Hello, everyone. Welcome to a talk in the Theory of Computation course. This is the first talk about streaming algorithms. But I will start by telling you a little bit about myself. So right now, I'm in the mathematics department in the Technion in Israel. Before that, I did my postdoc for 2 years in the Institute for Advanced Study. And before that, I did my PhD in the Weizmann Institute. My main interest, the thing I'm mostly interested in, is understanding how mathematics can help us understand and use computation in a better way. So this is how I think about computation, theory of computation. So this triangle represents mathematics. Mathematics has 3 components. The first component is definitions. Definitions are the way we define the framework. We lay down the axioms we want to work with. And this is the starting point of mathematics. After we explain everything formally, after we define the model, then we can make statements on the world we just defined. This is the second vertex, which is theorems. Then we can make claims about the world. And the last vertex in the triangle consists of proofs, which are ways to explain why the theorems are true. So this is a very brief and maybe high-level description of mathematics. And for me, the main thing that is interesting here in theory is that the connection between this very abstract internal world of ideas to the real world. So how can we use all of these mental constructs, these logical constructs, to understand the world better, to use it better? So this is the reason why I enjoy and why I try to follow this approach to science. So now I'm going to start discussing streaming, but I will start by explaining a slightly wider perspective, my perspective on a larger scale, on a higher level, and then we'll go to streaming. So the course is about the theory of computation. Inside this theory, there is the world of complexity, which I'm going to describe briefly next. And inside this world, there is the world of streaming algorithms, which is the topic of this lecture. And in this specific course, streaming, other than being interesting by itself, is a model that allows us to move relatively naturally from the model of finite automata, which is the thing you already discussed. And the model we really want to get to is the model of Turing machines. This will be done next. And streaming is a way to move from this world into this world, sort of a hybrid model between the two worlds. So this is one of the purposes of this model in this course. Before I will give some introduction to streaming, I want to give even more basic introduction to computational complexity. So the goal of this theory is to understand, using mathematics, how to use computational resources like time, the running time of an algorithm, the memory size of an algorithm, maybe the amount of randomness it uses, and any other computational resource you can think of. So this is the high-level goal of this theory. And the typical example of how you construct the theory is something like this. So there is some computational goal we wish to achieve, some function we wish to compute, or maybe some functionality we want to have. So this is the goal in the world. To do this, we have the current technology. So the theory is, here I call it devices. We have a family of functions, devices or objects. And examples that you saw is a device can be a finite automaton. Later, a device will be a Turing machine, and maybe a Boolean circuits, or maybe a communication protocol. So there are many ways to define what are the devices we are looking at. And the family of devices we choose has two components, has two properties. One is a device computes a function. Devices have functionalities. This is one aspect. The other aspect is with a device we can associate a cost. The cost can be the size of the device, like the size of the finite automaton. It can be the running time. It can be the memory size. It can be various other things. So devices have functionalities and devices have costs. And now what we really want to do is to have some functionality. The device is just a model for our technology. So the real goal we have is to compute some function that we are interested in. And now, after we have we defined what are the devices we care about, we can define the complexity of a function. The complexity of a function is the minimum cost of a device that computes it. So devices have costs, functions have complexities, which is the minimum cost for computing it. And the goal of the theory, the high-level goal of the theory, is to understand this number. There is some function f that we care about, and then we want to understand what is its complexity. This is the goal of the theory. And this question has two aspects. One is proving that this number is not too large. This typically comes by finding an algorithm for solving this problem. This is called upper bounds. And the other is to show that this number cannot be too small, that it's impossible to compute this function too efficiently or with very low cost. And this is typically called lower bounds. So this is the main question in computational complexity theory, and it has two aspects. And today we are going to focus on a very specific family of devices, and this is the devices that correspond to streaming algorithms or streaming in general. And so first, the model starts with a story. What is the story we want to capture? We want to model. So the story is that there is a stream of data. This means that there is a list of examples we see. So there is a data that arrives sequentially, one after the other. And there are many examples for such data. There is, you can think about it as a video or a camera feed. It can be the sound or a song. It can be the traffic of a computer network in some router. And it can also be the data that a machine learning algorithm gets, either while in the training process or in the real world where it interacts with reality. So this is the scenario we are interested in. This is the streaming scenario. And now the question that is we want to understand by defining a model and then trying to prove things about this model is, what can we do in this scenario? What are our options? So one thing we can do with this data, if it's a video, we can just play the video, right? We can play the movie or the song, and this is sometimes enough. This does not, playing the video or the song does not require a lot of resources. We can also record the data. We can put it on the hard drive, but this starts to have cost. So maybe we cannot record it indefinitely. Another thing that we can do with this sequence of bits or images is to hide things in it and maybe to communicate to some other party, something that will be hard to detect. This is a third option that you can do. The fourth option I'm mentioning is maybe we can, in the specific objective we have in mind, maybe we can find a very clever way to manipulate the data to achieve our goal. So we want to find an algorithm. And maybe we can't do anything with it with the current technology, or maybe with any technology. This is, maybe we can prove a lower bound, some impossibility result. So these are just some options that are available in this scenario. And in this lecture, what we're going to focus on is on the on the two last objectives, is discuss a little bit of algorithms but mostly understanding how can we prove impossibility results in this framework. And keep in mind that this framework is a hybrid between finite automata that you already know and Turing machines that you will see later, and the underlying definition is more complicated. So this allows us to move from the two models. And I want to just summarize this talk. We will have two more talks in this lecture. So today I gave you a brief introduction or a high-level introduction to computational complexity theory. And then we saw a few examples or a few questions that come with a streaming scenario where the data arrives sequentially. The next lecture will be much more formal. We will see examples. We will define a model, a formal model, and prove some things on this model. And in the third talk, we will discuss a wider perspective, and it will be again less formal. So the next talk will be very formal, and the last talk will be again a bit of higher level. So I hope to see you in the next talk, and we will end this one.